Unit 4A, Lesson 1. In this unit, we're going to be focusing on statistics and probabilities. In this first lesson, we're going to work with normal distributions and standard deviations. The first thing we need to talk about is standard deviation, which allows us to calculate, if we have a set of data that follows a normal distribution, how far away from the mean or average we are. So we have our basic formula, S equals the square root of the summation of x minus x bar, that quantity squared, all divided by n. S represents the standard deviation of a sample set. Sigma, the capital sigma, means sum of. We're going to take the addition of many terms. X represents each value in our data set. X bar represents the mean of our set of data. And n represents the number of values in the data set. One thing to be aware of is that we can replace s with the Greek symbol lowercase sigma. This is often used to represent standard deviation. We can also replace x bar, which represents the average, with the Greek letter mu. So be aware, we're probably going to use mu and lowercase sigma when dealing with the formula for standard deviation. Now we need to talk about the normal distribution curve, often called the bell-shaped curve, which you can see down below. It looks like a bell, thus the name. It's also referred to as the Gaussian distribution. There's some characteristics we're going to go through that usually follow a bell-shaped curve. First, the mean or average is always the center of the bell curve. You can see that down below. The center of our point, that is going to represent the average of our data set. The second one we're not going to work with as much. Basically, that just tells us that our normal distribution could have one peak or two peaks or three peaks, so on and so forth. The one down below only has one peak, and that's the type of data sets we're going to start out working with. The third one tells us that a bell curve has predictable standard deviations that follow the 68, 95, and 99.7 rule. We'll talk about that here in a little bit. Then the fourth one, a bell curve is symmetric, which you can see down below. If we look at the average or mean, and we use that as our axis of symmetry, we can see we have the mirrored image created about that axis of symmetry. So half of our data points are going to be to the left, and half of our points are going to be to the right of our mean for our data set. Now we need to talk about how standard deviations are incorporated into the bell-shaped curve. So if we're at our center or average, if we go one standard deviation to the right or one standard deviation to the left, if we take all the data points within one standard deviation of our mean, that is going to account for 68% of our data. 34% of it is going to be to the left of the average, and 34% of it is going to be to the right of the average. If I start at the mean and I go two standard deviations to the right and two standard deviations to the left, now if I add up all these percentages, that is going to account for 95% of my data points. So if we look at rule 3, 68% accounts for one standard deviation. If we go to two standard deviations away from our mean, that accounts for 95% of our data. Now if we would go to our mean, our average, and now go three standard deviations to the right and three standard deviations to the left, now that is going to basically account for all of our data points in our data set. So these percentages you have to become familiar with because these percentages are consistent with normal distribution curves. So the first example we're going to go through is find the standard deviation for the data set. So we have the set of points 9, 2, 5, 4, 12, 7, 8, and 11. The formula we're going to use is sigma equals, this stands for the standard deviation is equal to the square root of the sum of the terms x minus mu, that quantity squared, all divided by n. Remember that x represents all of the data points in our set. Mu is the average of all of our data points, and then n is the number of data points we have. The first thing to find is the value of mu, the average. So if we add up all of the points in our data set, divide by the number of points there are, that is equal to 7.25. And also we needed to find the value of n, the number of terms, which we already had to find if we found the average. So the number of terms, our data points, was 8. Now if we plug in all of our information into our formula for the standard deviation, notice I'm taking each of the points in my data set minus the average and then squaring that quantity. Notice the 9, the 2, the 5, 4, 12, 7, 8, and 11 are the original data points. I'm subtracting the average from each of those data points and then squaring that value. Once we add up all of those, that's what the summation stands for, adding up all those terms. We divide them by the number of terms, which was 8, and then take the square root of that result. If you're plugging this in on a calculator, which I recommend you do, I would first add up all of these terms, get your answer, then divide that answer by 8, get your value, and then take the square root of that value. Do this in multiple steps rather than trying to type this all in at once. And so if you type that in, you get sigma is approximately 3.2. So that's how far to the right or left one standard deviation would be from our average. Now we're going to use ideas from the normal distribution curve and standard deviations to answer the following question. The scores on an exam follow a normal distribution. The mean of the scores is 68 and the standard deviation is 6. What is the approximate percent of students that had a score between 62 and 74? I think the easiest thing to do in this problem would be to draw a rough sketch of a bell-shaped curve and fill in the information we know. We know the mean score is 68, so that has to be in the middle of our bell-shaped curve, splitting it in those symmetric halves. We're also told the standard deviation is 6 units, so if this is my average and my first standard deviation is a value of 6, that means this value must be 74. 68 plus 6 is 74. If I go one standard deviation of 6 to the left, I would subtract 6 from 68, which is where I get the 62. So our question was to approximate the percent of students that had a score between 62 and 74. So we're looking for this percentage of students underneath our curve. So this is where you have to basically memorize those percentages underneath the bell-shaped curve. If we go one standard deviation to the left, that accounts for 34%. If we go one standard deviation to the right, that accounts for another 34%. So the approximate percent of students that had a score between 62 and 74, if we add those two percentages together, would be 68% of the students. Our last example is going to follow a similar idea. The scores on an exam follow a normal distribution. The mean of the scores is 72 and the standard deviation is 7. What is the approximate range of scores that 95% of the students would have? Again, I'm going to start out by drawing a bell-shaped curve to give me an idea of what I'm looking at. Plotting the bell-shaped curve, I know my average, the mean, is 72. We also talked about this in the last problem. If I would go one standard deviation to the left, that accounts for 34% of my data points. One standard deviation to the right is another 34%. If I would go two standard deviations to the right, the portion between one standard deviation and two standard deviations accounts for 13.5%. Same thing on the left. If I go between one standard deviation and two standard deviations, that accounts for 13.5%. So if I would add up all of these percentages from two standard deviations to the left and to the right, that accounts for 95% of my data points. So now I have to use the idea that the standard deviation is 7 to find these endpoints. If I would go one standard deviation to the right, I would add 7, which would get me 79, and add another 7, which would get me 86. Using the same idea, if we go a standard deviation of 7 to the left, 72 minus 7 is going to give us 65. And then another 7 to the left is going to give us 58. So this means that 95% of the students would have a score between 58 and 86. In this lesson, we talked about many new ideas. You need to recognize the formula to calculate a standard deviation. Use lowercase sigma instead of s to stand for the standard deviation, and use mu instead of x bar to stand for the average. You also need to know the percentages for these regions underneath our normal distribution curve for intervals between 1 standard deviation, 2 standard deviations, and 3 standard deviations away from the mean.